So here's a system of equations to solve. I'm going to take the first equation and solve it, I believe, for x. So 3x plus 5y equals -1. 3x will equal -5y minus 1. And x will equal -5/3 y minus 1/3. So I've solved it for x. I substitute that into the other equation. So now I have 6 times -5/3 y minus 1/3, still plus the 2y equals 14. 3 goes into 6 2 times, so -10y. 3 goes into 6 2 times, so times the 1 will be -2, plus 2y equals 14. Combining like terms here, I'll have -8y equals, adding 2 to both sides, equals 16, and I find that y equals -2. I substitute that back into this equation. X equals -5/3 times -2 minus 1/3. So this will be 10/3 minus 1/3. So x will equal 9/3, or x equals 3. Substituting that into the other equation, 6 times 3 is 18, plus 2 times -2, so -4. 18 plus -4 is 14, and those answers check. We can also solve by elimination. We write one or both of the equations in equivalent form that allows us to eliminate one of the variables by adding or subtracting the equations. To solve a system of 2 equations and 2 variables by elimination, if necessary, multiply one or both equations by a non-zero number that will make the coefficients of one of the variables in the equations equal, except for facts-based signs. So maybe you end up with a 3 and a -3. Add or subtract those equations to eliminate one of the variables. Then you'll have an equation, a linear equation in one variable. Solve for that one variable, substitute that into one of the original equations and solve for the second variable, and you can check it by the solution in the remaining original equation or graphically. So here we actually have the same 2 equations, but let's show how we would do those by elimination. I'm going to take the top equation times -2. That will give me a -6x minus 10y equals 2. And leaving the bottom equation the same, I'm going to add those 2 equations together. -6x and 6x, they're gone. -10y plus 2y will give me -8y equals 2 plus 14 is 16. And y equals -2. Should get the same answer I did before. Then substitute that into one of the equations. 6x plus 2 times -2 equals 14. 6x minus 4 equals 14. 6x will equal 18, and x equals 3. Same solutions I had before, so we would check it by the other equation. 3 times 3 is 9, plus 5 times -2, -10. 9 plus -10 would be -1, and they do check. Now, solutions to real problems sometimes require us to create 2 or more equations whose simultaneous solution is a solution to the problem. So here we have to make the equations. An investor has $200,000 to invest, part at 8% and the remainder at 3%. If her investment goal is to have an annual income of $13,600, how much should she put in each investment? Well, her income will be the interest. So interest equals the principal times the rate times the time, and it's annual interest, so here our time will be 1 year. So if we say X is the 8% value and Y is the 3% value, we want the 8% value. Oh, and we know we're going to split this $200,000. So first, X plus Y equals 200,000. That's my first equation. And then using this, where T is 1, the interest from the first investment would be that X amount times 8%, which we changed to 0.08, X plus the Y interest would be 0.03 times Y. We want that to equal our $13,600. I'm going to take my top equation times -3. That will give me -3x minus 3y equals -600,000. And I'm going to take my bottom equation times 100 because I'm not really fond of working with decimals. So that will give me 8x plus 3y equals, I'll have to add 2 zeros on this. It will equal 1,360,000. Adding those two, I'll end up with -3x and 8x is 5x, -3y and +3y, they're gone. And here I will subtract the 600,000 from the 1,360,000. I'll get 760,000. And dividing by 5, X turns out to be $152,000. Now we know X plus Y equals 200,000, so we can find out that Y equals 48,000. Stating this answer, he's going to invest $152,000 at 8%. Don't know why this is making such funny numbers right now. And $48,000 at 3%. I really don't know why those making strange numbers. I'm going to put my $sign on. So this would be my solution.